NASA's most advanced rover just sent back something scientists weren't expecting to find at this scale. From orbit, it looks like ordinary Martian ground. Rust-colored, empty, familiar, but up close, it looks almost impossible. A landscape built entirely out of repeating shapes, thousands of them. Interlocking, endless, stretching farther than the rover's own cameras can see. What exactly did NASA find out there? And why are scientists calling this one of the strangest things Curiosity has ever photographed? That's exactly what we're about to uncover. Somewhere inside a valley on Mars that scientists nicknamed Valley Grande, a rover the size of a small car has been climbing, slowly, patiently, for weeks. And on 2 ordinary days this past June, it stopped, turned its camera in a full circle, and captured something that even veteran NASA scientists weren't ready for. But to understand why this discovery matters, we have to go back 13 years to the day a spacecraft the size of a small SUV was lowered onto the Martian surface by a hovering sky crane in what NASA itself once called 7 minutes of terror. That was August 2012. And ever since, Curiosity has been doing one thing: climbing. Its destination is Mount Sharp, a mountain over 3 miles tall, rising from the center of Gale Crater like a monument built by time itself. Scientists believe that billions of years ago, this crater wasn't a crater at all. It was a lake. Streams fed into it, water pooled at its center, and layer by layer, the sediments of that ancient lake became the mountain Curiosity is climbing today. Every layer Curiosity passes is a page further back in time. But nothing prepared the team for what waited in Valley Grande. In mid-June of 2026, as Curiosity pushed further up the valley, its cameras began picking up a texture the mission had seen before, just never like this. Small, tightly packed shapes, each one only a few centimeters wide, fitting together edge to edge, almost like the surface had been engineered. They call them polygonal fractures. And individually, they're nothing new. Curiosity has spotted patches of them scattered across Gale Crater for years, but this time was different. On June 19th and 20th, the rover captured a full 360-degree panorama stitched together from over 300 separate images. And when scientists pieced it together back on Earth, what they saw stopped them cold. The polygons didn't stop at the edge of the frame. They didn't fade out into normal ground. They kept going, in every direction, as far as the camera could physically resolve. Even more strangely, the pattern wrapped itself around the base of a nearby rock formation the team nicknamed Neuroverse, a butte roughly 20 feet tall, capped with a thick layer of sand. The mission's project scientist described it simply. This sea of polygons, he said, took the team's breath away. They had never seen this many of these features in one place before, anywhere on Mars. So the question became unavoidable. What could carve a pattern this size, this precise, into an entire planet's surface? Here's where it's tempting to let the imagination run wild. A pattern this vast, this geometric, almost feels engineered. But NASA has been direct about what this is, and just as importantly, what it isn't. There's no evidence of structures, no evidence of technology, no evidence of anything built. What scientists are looking at is a naturally occurring geological texture, and Earth has its own version of it in nearly every desert, lakebed, and permafrost field on the planet. You've probably seen it yourself. A dried-up puddle in summer cracked into a mosaic of little hexagons and pentagons. That's the same basic physics, just scaled up into something almost otherworldly on Mars. When wet sediment dries out, it shrinks. But it can't shrink evenly, so it fractures, relieving the stress in a pattern that nature tends to repeat again and again. Whether it's happening in a Martian valley or a dry lakebed in Nevada, that's one explanation. But NASA is careful to note it's not the only one, because on Mars, more than one process could produce a texture like this. The first possibility is exactly what it looks like on Earth: mud, drying and cracking under an ancient sun. Billions of years ago, if Gale Crater really was a lake, then a valley like this one could have been shoreline, or a floodplain, repeatedly soaked and then baked dry. But there's a second possibility, and it's a little more subtle. Cycles of freezing and thawing could have stressed the ground the same way, expanding and contracting the material over and over until it split along these same efficient lines. And there's a third. Long after the sediment first formed, deep burial under later layers of rock may have compressed it, squeezing out trapped water and fracturing the surface from the inside, long before erosion ever exposed it to Curiosity's cameras. Three very different histories, all capable of producing the same haunting pattern. And right now, nobody is entirely sure which one actually happened here. That's not a failure of the mission. That's the mystery the mission exists to solve. So why does any of this matter? Why should a field of cracked rock, however strange it looks, change the way we think about an entire planet? Because every one of these explanations requires water. Mud cracks need standing water that evaporated. Freeze-thaw cycles need moisture trapped in the ground. Even the burial and compaction theory requires water that was later squeezed out of the rock. Whichever process shaped Valley Grande, water was almost certainly involved at a scale big enough to leave a fingerprint this size across the landscape. The surface of Mars remembers what its atmosphere has forgotten. And that's the real story here. Not a mystery pattern for its own sake, but a planet-sized clue about a world that may once have looked far more like our own than the frozen desert we see today. Which raises the next question scientists can't stop asking. If Valley Grande really was shaped by ancient water, cycling through wet and dry seasons, or freezing and thawing across the ground, then for a period of Martian history, this valley may have been an environment capable of supporting the basic chemistry of life, not evidence of life. NASA is careful never to claim that, but evidence of the conditions life would need: water, chemistry, and enough stability over time for those processes to leave a mark this size behind. Every crack in this ancient landscape is a page from a planetary history book. The question Curiosity is now trying to answer isn't just how the polygons formed, it's what kind of Mars could have formed them. So what happens next? The mission team isn't done with Valley Grande. They've already begun measuring the shape and chemical composition of the polygons more closely, hoping the fine details, the mineral makeup, the precise geometry of each crack will finally point toward one explanation over the others. Curiosity will keep climbing. Higher up Mount Sharp, through layers scientists believe represent a Mars that grew progressively drier and harsher over time. Somewhere in those upper layers may be the answer to an even bigger question, not just when Mars had water, but when and why it finally lost it for good. Sometimes the biggest discoveries aren't what we find, they're what they force us to question. It's easy to forget just how remarkable it is that we know any of this at all. A machine built by human hands is currently sitting on the surface of another planet, 100 million miles from home, patiently photographing cracks in the dirt because those cracks might tell us whether that world was ever alive. The universe rarely gives us answers, it gives us clues. And 13 years into its mission, Curiosity just found one of the biggest clues yet, written across an entire valley, one polygon at a time. The red planet has remained silent for billions of years. Yet with every meter Curiosity travels, Mars whispers another piece of its forgotten story. And perhaps the greatest discovery is still waiting just beyond the next horizon. This is Neuroverse, where every mystery brings us one step closer to understanding the universe. But Curiosity isn't NASA's only explorer making history right now, because another mission may have just found something even more astonishing. We'll uncover that next.